Hi, my name is Samuel Raumin. I am a electrical/computer engineer. I am also the cybersecurity, leader, director of FAST. So today we're going to be kind of discussing about Linux, or the full term is GNU Linux, but we're going to be kind of diverging into a lot of different topics today. Really just for beginners. You don't need to have any sort of previous experience in Linux or really any kind of operating system for that matter to work with and start with this course. So some of the things we're going to be covering today, we're going to be kind of talking about why Linux is a little bit different from the rest. We're going to be talking about kind of the pros and cons of Linux and its usages. We're going to kind of just briefly go into the history of Linux. I can talk about that for a long time, but realistically, we shouldn't. We're going to be teaching you how to set up a Linux VM environment today so that you guys will be able to do and work with the commands so that you can, firsthand understand what is going on so you can actually work with it and see how it actually interacts. Realistically, what we're going to be doing today is going to be applied to any sort of VM environment that you ever want to work with, whether it be through Linux or Windows or Macintosh or anything like that. We're going to be kind of looking into various kinds of commands. We're going to be kind of navigating, viewing, opening, executing, changing file permissions, updates. We're going to be doing a lot of different stuff, and we're really only going to be using the terminal window. We're not going to be relying on the desktop at all, right? Because that's, you might as well just use Windows if you're going to do that. So we're going to kind of teach you how to become more comfortable with the terminal screen. A lot of people, when they come to me, one of the biggest things that they fear is just that blank terminal screen because they do not know how to interact with it. And that's kind of scary for a lot of people. So we'll be kind of going into that and kind of teaching you. We're going to be kind of talking about utilizing and properly managing different kinds of tools. We're not going to be using Kali Linux today, but I will be kind of talking about, afterwards, if people are interested about kind of the more specific areas that you can cover with different kinds of distros. And then I'm also going to be kind of leading you with some reading material on how to get you to becoming a super user, which is basically the term meaning that you really do know how to use Linux and you're a power user, basically. So we're going to kind of be talking about the differences. So the first main difference is that Linux is open source. And that means that pretty much anybody is allowed to use or modify the kernel to their heart's content. There is no copyright restrictions. There's really nothing that stands in the way of making it so that somebody else can take the material. And if they really wanted to, they can completely change it to make it something else, right? They can make it something of a new kind of distribution that doesn't exist. And we will be talking about that more later. Anyone can submit patches. A patch is basically just a piece of code or a debug or something that somebody brought up to fix a reoccurring or possibly a new problem that is noticed inside of the Linux GNU kernel. There's a kind of a hierarchy as to how these patches are assembled, and then eventually they are evaluated, and then eventually they are passed to the main code. The final say for any kind of kernel update really goes to Linus Torvalds, I totally butchered that. Linus Torvalds is the guy who created Linux, End of Linux, and he's the kind of final say as to what piece of code or patch is eventually pushed to the end. There's also a set of maintainers. I believe it's like roughly 100,000 senior developers are the maintainers, and they're the ones who kind of look at all the different places that people submit patches, and they gather them, collect them, and then they can create reports so that they can eventually get those patches rolled out efficiently. One of the biggest reasons why it's so successful is because it's free to use, and really the reason behind that is because it's open source, right? Because it's open source and people can use it, in order for people to basically work with it, one of the incentives that they have to give is it's free. So any kind of distribution that you're going to work with, unless you're paying for any kind of like service that somebody else is like pre-hosting for you or something like that, you're really not going to need to pay at all to use it. And you still get support, which is kind of neat. So now we're going to kind of talk about like distros. So distributions or distros or flavors are made by a bunch of different groups or individuals. They basically take the Linux kernel and they say, okay, well, I kind of want to make something else that doesn't exist. And that's realistically what happens across every single kind of distribution that exists. So they're unique to that distro's developer, right? So whoever, or developers, that's whoever made that distribution, it's going to employ the features of what that developer chose was going to be in that. There are many like more generally specific distros that exist. There's Ubuntu, Mint, Arch, Gentoo, and there's a lot more. But those are just kind of the ones that popped into my head. And then there's some that are more specialized, such as Red Hat or Kali, Pentoo, or Hannah Montana Linux. It's lightweight. It's very lightweight. It doesn't have as many dependencies as most of these other operating systems, where I guess in like the case of Windows, they try to build upon stuff that was already pre-built. And I suppose Linux does do the same thing, but usually when you have a system where Linux is updated every day instead of, every week, like Windows, there's a lot of like rapid change that's occurring. And because of that rapid change like nature, the Linux OS is very polished, right? So, it has a very to the point structure, and it just makes sense, right? Of course, there are ways that you can make certain kinds of distributions more lightweight. You can disable GUI elements, so you can just turn off the desktop and really just work within shell commands, and that's what we're kind of going to be going into today. And there also are more lightweight distributions. Arch Linux is basically a very bleeding edge, right? You can get very unstable releases of patches if you really want to on Linux distributions, and Arch Linux is no exception to that. In fact, most Arch Linux users, from what I understand, pride themselves on the fact that it is so lightweight, and I can understand that. So realistically speaking, Linux can pretty much run on any kind of repurposed server, right? Like pretty much every Linux server that I have running is a repurposed computer, right? And that's perfectly fine, because although they can't run like Windows 10 and all that kind of stuff, it doesn't mean it's useless. I mean, it means, if anything, it's more usable after you install Linux and you give it life again, a purpose, right? And that makes me feel good inside, knowing that I gave purpose to another computer. So there are pros definitely to Linux. The pros is that it's lightweight, so therefore usually lower specs are typically usable. It's a very to the point distribution tradition. So usually they don't, unless really otherwise specified, there isn't like a ton of bloatware or adware or any of that kind of junk that you really don't want on an operating system that you're never going to use, right? It's very to the point if you really want it to be that way. It's a very supportive community. There's a ton of people who are really willing to help you if you just know how to ask the question. And chances are, if it's a pretty general question, you're probably going to find it on Stack Overflow, or any other, I guess, forum base. It's very transparent. If you want to know what was updated yesterday, you can see, you can find it. You can find what needs to be updated. You don't have to update certain packets. It's a very coherent and transparent system. So with that being said, it does have a little bit of a different, but much more clear user and group hierarchy, right? In terms of organization for Linux, it's a little bit different than most other operating systems that you may be used to, but for the most part, it's kind of like, who cares, right? The first time the first time that a lot of people begin to learn the idea of user and groups is when they are introduced to Linux. So to have just a nice system to begin with when you're first learning it, makes all the difference. It's full of user control. You can customize Linux literally however you want, right? I mean, you can pick and pull and choose whatever you want, right? And you can make it yours, right? And that's something that I definitely pride myself on, especially since the fact that I work with computers quite a bit, and you guys all probably do too. So it's very security oriented, and it does focus on privacy. Wink, wink, right? I mean, to the group that I'm talking to here, this is a very big thing, right? It's focused on security. It was built on the idea of security, right? Within that in mind, you have a better time working with software that is much more privacy oriented when you're working with Linux. So That's always a plus. It's free to use again. It's easy to install with initial guidance. I have a story that you guys can ask about a little bit later in the lecture if you want. That kind of talks about my first experience with installing Linux and how that was an absolute headache. But really, if you have a good understanding of partition tables and kind of just how a hard drive works in terms of properly allocating things, at which we can also talk about what proper partitions Linux is required, then you should be fine. Almost always, I kid you not, the second server that I actually have Linux running on is on a 2011 Intel Enterprise server. It's got two Xeon Core processors inside of it, and this thing is just a mammoth, right? And I kid you not, I was thinking when I was loading Linux on this thing, it's like there's no way this thing is going to run, right? Because I didn't think that this thing even had support to have Linux running on it. It ran just fine. I think the only thing that broke was the temperature sensors, which is what I need to fix. So for the most part, it's going to have full, I can guarantee you whatever computer you're going to probably be able to find, if it follows under the specifications, it's going to run. One downfall, and I guess this is an upside too, is that usually the software that you're used to in Windows is not exactly built for Linux, but there's definitely a lot more people, a lot more companies that are starting to kind of slowly move their software to Linux support, and that's just kind of the nature of the deal. It's a big wish, but it makes you, I guess, appreciate the fact that there is a company who did spend the time to port a software for you over to Linux. So, and of course, the final pro is that their mascot's a penguin. I mean, how can you be upset about that, right? I mean, what's the Windows mascot? A window? Yeah, you can't relate to that. There are no cons. No, I'm just kidding.
You don't know me. I can relate to a window.
Yeah. Now, when we talk about cons, there is a learning curve, right? But of course, that's why you are here, right? So that we can help you get on the horse, so that we can set you off to becoming the Linux super user that you also dearly want to be. There are other kinds of, things that beginners kind of run into, LTS, which means just whatever the standard software is from Ubuntu or any kind of main supportive line current software. And terminal-based interactions can be kind of dry for beginners. It's kind of hard for somebody who's so used to all the eye candy that GUIs produce to really appreciate and use something that literally is just a terminal screen. But I promise you there are ways that you can make that a little bit more fun for yourself. Starting points can be vague. The reason I'm saying this is because when I was first learning Linux, I had no idea where to start, right? I mean, I was just I don't even know how to install, this operating system to begin with. Where do I even begin? And then people were telling me about VMs, and I'm like, what's a VM, right? So it's if you have no idea, it can be very daunting and almost just a turnoff. So that's, there's that, right? And again, you lose support for software that you may like a lot because you're really used to it. And then, but of course, there are ways that there are alternatives, right? There are Linux alternatives that do exist. And if you're willing to learn that new software, then great. But if not, you can always have dual booting, or you can have a system that has, one hard drive that has Windows on it and then another hard drive that has Linux on it. There's nothing wrong with that, right? So now we're going to be kind of talking about the history of Linux. So in 1994, Linux was released, Linux 1.0. There were kind of people who had stuff that was before Linux 1.0, but that was really only within the small group that actually knew these two gentlemen. Richard Stallman and Linus Torvalds basically combined their software together in 1994. Richard Stallman was working on a kernel type that was called GNU around the same time that Linus Torvalds was, and Linus Torvalds was called Linux. So when they actually combined them, they called it the GNU Linux kernel, right? And that's what it was. But a lot of people have kind of pushed away the GNU part of it because I believe realistically Richard Stallman and Linus Torvalds had a really bad fallout, and Linus pretty much just took over the whole deal. So there isn't really like a whole lot of Richard Stallman work inside of the current systems anymore, unless you like really look deep at some of the pre-existing kernel base and everything like that. You're not going to find that much anymore, which is too bad, because they both are really brilliant guys. I believe actually Richard Stallman went to Stanford, got a degree in physics, but then also got to work at MIT with their artificial intelligence lab, and that's where he developed GNU. And Linus Torvalds, when he was working, he's a Finnish programmer. When he was working in the States, he was also working alongside some very brilliant people. Likewise, the guy who actually later created Oracle. So that was kind of a hotspot for geniuses. So before we begin, there's actually just some reading material that if you guys are further interested in kind of understanding what we're going to be going over today, this is the stuff that I looked at. All of them are pretty much free to find online, because No Starch Press has a really cool policy with like publishing PDFs of their stuff, and that's really cool, because realistically these are probably some of the greatest books I think I've ever read talking about all this. So there's these books. If any of you are kind of having trouble finding the text or anything like that, you guys can ask me afterwards, and I'll be able to equip you with the text. So I guess we should probably get going. Okay, so if you guys saw the thing before, when I was kind of, when we were first kind of starting this thing, we wanted to make sure that you guys downloaded two things. We wanted you to download the Oracle software, the VM software, and we also are going to we wanted you to download the Ubuntu ISO distribution image, right? And if you haven't, that's no big deal. That's kind of why I made it, so that we can have some time to do this. Here are the actual install links. Is everybody here good? Like, did everybody install what they were supposed to, or at least download it? We were going to be going over how to set up the VM in class today, but at least downloading it, we wanted to kind of get that through.
I did not download it yet.
You did not. Okay. All right. No big deal. I kind of had a feeling there was going to be a few people like that, so that's no big deal. These links right here, I can actually post them in the chat if you want, if that's easier for you guys.
Just did.
Okay, thank you.
So it actually says everyone in waiting room, Finn. If we can change to just everyone in chat.
Thank you for that.
Got you, boss.
So are we fixing something? Sorry. Oh, oopsies.
No, I just directed the chat to the waiting room instead of the meeting room. That was my bad, but it's all good now.
Okay. So we're going to kind of get rolling. Now we're going to kind of set up the help me out, the VM right now. So here's what we're going to do. I have my VM actually open right here, and this is kind of what it's going to look like. Of course, I can kind of teach you how to scale it a little bit better. So I'm just going to shut this off so I can kind of show you sort of how to, oops, I'm just going to turn it off actually. So I can just kind of show you how everything works with this. So this is the screen you're going to see. Okay, you're not going to see anything over here because this is my setup right here. Okay, so what you're going to do is you're going to click on New on the top here, and you can just name it whatever, right? You just want to name it Ubuntu probably. You want to change this directory to wherever you want the machine's directory information to be stored, right? So all the information that you're going to be storing in the VM. So like if you have an additional storage drive, make sure to set it up, you properly point the directory to that correct storage drive. Are you all good? Okay,
I'll figure it out.
All right. So what you're going to do, you're going to leave these as pretty much, I think these are the defaults, but just make sure that it's on Linux and that it's on Ubuntu and it's on 64-bit. I'm assuming that everybody's computer on here is 64-bit.
16, actually.
Okay. Well, you're kind of out of luck. Okay, so this is just your memory dedication. Realistically, you would probably want to maybe set like, I don't know, minimum 2 gigabytes worth of memory, right? It kind of depends on what you guys are running on right now. But safe, super safe, is to drag it somewhere like in the middle of the green, and then you're safe. That's like the safe thing. It auto assumes basically how much memory you have to give, and then if you drag it in the middle green, you'll be fine, and just don't really worry about that. So you probably wanted to create a virtual hard disk drive. That basically just means that it's creating a partition, like a fake virtual partition inside of your hard drive. Don't worry about it. Just make sure you have 10 gigabytes worth of space on your hard drive. And then you're going to press create. Okay. Leave this as default. This is fine. You can choose if you want it to be like a fixed size or dynamically allocated. Since realistically we're going to be doing so little, dynamically allocated is probably best. So that's fine. And then from here, this is going to be where your file location information is going to be stored. So it's really going to just take the previous, directory that you set, and then it's going to place it in here, just creating another directory. So 10 gigabytes, like I said, is perfect. It's enough. It should be fine. And then you just press create. Okay. So now you're going to see something called Ubuntu. Okay. Is everybody doing okay so far? Ferris Rocks 22. So what you're then going to do is you're going to click on settings. You're going to go to storage. You're going to click on this little optical disk image button right here. You're going to then click add, and you're going to locate, so it's going to be in your downloads. You're going to locate the file that you downloaded, the Ubuntu file. So you're going to click on that, and then you're going to press open. So it's going to load it onto here, and then you basically just make sure that it's selected and you press choose. Okay. And then you just press OK, and then you can click start. And it's going to run you through the kind of the setup process to making your actual you're setting up your actual operating system. Does anybody not follow before we start up the OS? Does anybody not follow at all?
I think we're all good.
All good? No problems?
Looks like it.
You guys are doing pretty well. Okay, cool. So what you're going to do is you're going to press start on the top here, and it's going to run up the environment. Okay, and then, yep, so it's going to select the startup disk that you said, so you just press start. It's going to load it up. So it's going to kind of go through and just kind of check everything. You can kind of click out of the dialog that's giving you. So now it's going to run through and basically check the virtual disk space that you created. Make sure that you're make sure everything is working just fine. All right. This part usually does kind of take a while, but that's why we're all here experiencing this pain together. Yes, you can play Fortnite on this virtual machine, although I do not suggest it.
Play Among Us.
I think Mike, okay. You're on mute. I don't know if you were talking or trying to talk.
Oh. Oh yeah, and you also hear that really cool boot up screen. If you guys caught that.
Oh, nice. That's their new wallpaper.
Okay, so what you're gonna do? Yeah, that's because it's on 20.04. So now it's not Bionic Beaver anymore. Okay, So what we're going to do then is now, once you're kind of in the loading screen, you're just going to click on Install Ubuntu. And then just kind of go with the defaults unless you're used to some other kind of keyboard. Okay. So, you know what? Maybe what you're going to do is I'm going to have you uncheck the download updates while installing Ubuntu. Okay. That way I can kind of show you a command we're going to be talking about today. And then I also want you to click on minimal installation. You can click on normal, but it's going to take a lot longer. So just kind of click on the minimal one because we're not going to be using the full desktop anyways. So just press continue. Is everybody doing okay so far? Oh yeah. Okay, so now you're just going to click on erase disk and install Ubuntu. That's perfectly fine. It's not going to erase your disk. Keep that in mind. It's not going to damage anything on your actual hard drive. It's in its own container, right? So it's not going to touch your files at all. So don't worry. It's not going to do anything that's going to screw with your computer. That's what I'm hoping. No, I'm just kidding. I know it won't. It'll give you the correct time zone, I'm pretty sure, but I'm assuming, except for at least one of us who's in Wisconsin, it's going to give you the correct time zone. So just make sure that's good. And then this is the part where it's going to ask you what you want your system stuff to be. So I usually just name it test. And then you can choose a password, right? It can really just be anything. It doesn't matter.
A terrible password.
Okay, well, I'm sorry. We can go on KeyPass and make a very huge one if you want. So we press continue. And now it's going to run through the install process. And this is the part that's you can just kind of sit back and just watch for a little bit.
You're good.
Why am I even doing this? Man, I already have an environment.
Bro.
Get out of here. I don't want it. I already have an environment. Boom. Get out of here. Yeah, there we go. Okay, so here we go. So what I want you to do is when you're open with your VM, I want you to open the terminal. So you can click on the little bottom, click there, and you can type in terminal in the search bar, and you should be greeted to a terminal. Right, and just to kind of give you a little bit of information about what the terminal is telling you to begin with, you are logged in by looking here. You are logged in as the user test on the machine test VirtualBox, right? So that's something to know. And when you see this little prompt right here, that means it's waiting for a command. So let us begin. Okay, so before we begin, I kind of want to talk about the idea of arguments, okay? And I don't mean the arguments that you have with your mother because you want to move off during COVID for no reason at all. No, the argument that I'm talking about is the idea of a command, right? And specifying what kind of command and what you want that command to do. So for instance, one command that kind of came to mind when I was thinking about this was Java. And the Java command is basically used to interact with any kind of Java program when you have Java installed. So you can maybe kind of see where this is going if you have some experience, but the idea is that Java is just the call, right, to basically say, okay, use the Java command to do something, right? Now, when we look at this, I kind of expanded it, and I basically just said, okay, well, Java, right, but I need to tell Java program, what to do. I can't just say like Java, right? I want it to do something. Right? So what I have to tell Java is I want Java to basically launch the Minecraft file, right? So say you want to like start a server or something and you want to start up the process Minecraft using the Java runtime. But the problem is you're going to actually get an error with this. What's going to happen is it's going to say, okay, well, this isn't quite what I was looking for because the default isn't a .jar file, right? What you have to actually do is you have to specify that it is a jar file by just basically creating the argument -jar, right? And a lot of different kinds of calls, commands, use this argument-based how should I say, language to make it so that you are specifying correctly what you want the program or the command to perform, right? So, but it can be kind of like annoying a little bit too, because it's like, well, okay, there's so many different kinds of arguments, right? Because you can look at it even a step further and look at this. This is the full command, right? To basically run the Minecraft server the way I want it to, right? I want it to, what does this mean? What does this mean? Oh God, what is this? What does no GUI mean, right? You have no idea what any of this means, right? And well, unless you actually know what's going on, you really don't have any clue as to why you should include these arguments to begin with, right? So that's why there is one particular command that is incredibly useful, and that is the man command. So when we talk about the man command, it's short for the manual command. And basically it means that any kind of, shall I say, like any kind of command that you want to understand, you want to read the manual of it, you basically just type man and then the command, right? It's very straightforward. And I'll even kind of give you an example right now. So say I wanted to understand the man command for, I don't know, make dir, right? And what it will do is it'll bring up the actual, this is the actual manual to looking at the make dir command. And what you can do is you can use the arrow keys to scroll down, kind of look at the various line count as to, where you are in the manual. You can press H for more help, or you can press quit to basically exit outside of the, to exit outside of the manual, right? And this is, this works unless it's a shell command, right? So if you say man cd, there's going to be no entry for that, because the thing is it's built into the shell, and the manual command is operating system level. It's at higher levels than the, shall I say, like the make dir command or any of that kind of stuff, right? Like you can run cd in a recovery shell, and it won't have to make any reference to something, lower than what is currently presented for a manual, right? If that makes any sense at all. So sometimes the man command won't work for very basic shell commands. But in that case, if you ever really need help with that kind of stuff, you can just do cd help. Oops, I'm sorry. And then from there, you just do help cd, and it'll go through and basically tell you the, what you're looking for. So when it says options, those are usually telling you what are the allowed arguments and then what those arguments perform, right? Does that make any sense to everybody? Manception. Can you do that? Here, let's see. Interesting. So yes, you can actually manception it. So you can actually man the manual command since it's installed on the same time. That's a very good observation to take note of. And remember, you can scroll down or up using the arrow keys with the manual command. Okay. Alrighty, so the next thing we're going to look at is we're going to look at some of the basic commands. So these are just some of the commands that, helps you navigate around a given area, right? So the first command that we're going to look at is the cd command, which basically means change directory. Okay, so to get kind of an idea of where you are, you can type in pdw, which basically outputs to you what the current path is to where you are, right? So that's pretty straightforward. Now, say I want to go all the way to what's called the root directory. And the root directory is basically just the highest level, or maybe lowest, I guess, depending on how you look at it. But it's the highest or lowest level that you can get when you're working with a Linux-based system. It's almost always going to be the root folder, right? So the way to get to the root is you just type in cd and then just a slash, right? A /, right? You just click cd. So now it's telling you right here that you are in the root directory. As before, you were in the home directory. This little squiggly, this thing, generally means home directory of the user that you're talking about. So if you want to get back to your home directory, you just do cd squiggly, and it will bring you back. So, okay, well, that's all fine and dandy, Sam, but what if I want to know what is going on in the root directory? I want to see all the possible options that I can go into. Well, you can use the ls command. And the ls command will basically tell you every single place that you can go to, right? And you know, this is it, right? This is basically everything that is running Linux right now. So this is like everything that you will most likely ever see in a root directory or ever will need to see in a Linux root directory. All right, so, and then these are just basically directories. Kind of imagine it like your Windows system when you're traversing and, you know, going to your desktop or your downloads. They're different locations, right? So that's what these are. They're directories or different locations within your operating system. Okay, so now we're going to be kind of looking at, let's kind of go back to the home, okay? Because we don't want to screw around with any you know, root directory stuff. So now that we're inside of your back home, there's a couple cool commands that we can create. So one of the commands is just echo. Echo just basically means it'll voice back anything that you type in. So I can type in echo hello, and it'll repeat back what I told it to. There's a lot of other stuff you can do with echo. You can figure that out by just typing in man echo, and it'll tell you all the different, you know, it'll tell you the synopsis, so what is required. It can tell you necessarily what you can include. You can include a long option instead of a string. There's a bunch of different kinds of arguments that you can include that do a bunch of different weird stuff. This is like kind of the typecasting. So like if you wanted to use a new line or a form feed and escape, any of that kind of stuff, that's kind of how you would do it with echo. The cat command, well, I guess before we use the cat command, we should really just create a, we should learn how to create a file. So the way to create a file is we're going to use the command nano, okay? Now there's other ways that you can create like a blank file, right? Now one way you can do that is you can use the touch command, right? So you just say touch. Now obviously it's not going to tell you anything because the thing is that you didn't include an argument, right? So you want to say touch and then say text.txt, for instance, right? So now there's no response, so that's usually a good sign. That means that it created a test file called text, and we can look to double check by typing ls, and there it is, right? It's called test.txt, okay? Now, if we look at this text.txt and we think to ourselves, okay, well, it's empty, there's nothing in it. What if I want to populate it with something? Well, there's a bunch of different ways that you can do that, right? There's a bunch of different text editors that exist. There's Nano, there's Vim. Today, we're just going to be kind of going over Nano because it's a little bit easier to use. Vim is its own thing, and if you really do want to learn it, go ahead. And I do have resources for you to teach that. But what we're going to do is then we're going to type to populate the test.txt file. We're going to type in the command nano, right? So we're going to type in nano and then the file that obviously you want to edit. Capitalization matters. Spacing, all grammatical, you know, inputs matter. So just keep that in mind, right? Linux does take that very seriously. If you do not input the right thing, it's going to assume that you're trying to create another file, and it won't actually edit what you want. So once you finish the command, you hit enter, and it will bring you into the GNU Nano text editor, right? And this is where you can kind of start typing, right? So you can just type, you know, hello there, right? And that's pretty cool. And you can hit enter to go into a new line. And, you know, you can type whatever, just type whatever you want inside of it. And when you're done, basically all the commands written down here are basically what you can do to use the nano command. This little caret, that means control, right? So if you press control and then the other key, so in this case, we want to overwrite the file. So we want to make it so that everything we typed in here writes over the previous example of the test.txt so that it actually contains text. Once you know the text that you want it, you just type it, you just press control and then O. And it's going to ask you to confirm that you want to write it to that file, and it'll pick whatever file you were chosen, so just leave it default, just hit enter. And then it will tell you if it successfully wrote it, it'll say wrote 2 lines. If there's some kind of weird permission problem, which we will kind of look into, it'll tell you there was an error writing the information, and it won't actually, write the information unless you have the proper credentials to write that text file. So, okay, so once you're done, you've overridden the file and you have everything you want, you can exit by hitting Control X, right? So now you're back to the familiar screen that we looked at. And you could say, okay, well, that's kind of cool. But I already kind of forgot what's inside that text file. I don't know what I punched in there. Maybe it was notes or something like that. And I don't really feel like typing out nano and then, looking at the whole thing. What if I just want to like quickly display it? Well, that's super easy. All you have to do is you can use the command cat. And cat is short for concatenate, so you can technically actually combine file outputs together. But you can read that in the manual further for this command, but you can type in cat and then test. Now, here's the thing. Gosh, Sam, I don't really want to type out the full test.txt. What if I make a mistake? What if it's a really long file? What if it's something really stupid? Okay, well, how about I just allow Linux to autofill it? And it does have that ability. So what you can do is you can now I know that there's nothing in here, right? There's going to be 2 problems, right? I can hit tab and it's going to assume that I wanted to do text.txt, but I can also say, since this one is a folder, it knows necessarily I don't want to read, I don't want to cat the information coming from this folder. I want to cat the information from here. But let's say there was 2 text files. If you tried to hit tab to autocorrect it, it's going to bring you to that, but it's not going to autocomplete it because it's going to say, okay, well, do you want text.txt or like test2.txt? That's the problem. And I can even show you that. So we can say touch text2.txt. Right, and so now if we look, there's 2 of them. And if we do cat and we do test, notice it doesn't completely autofill it for me. It wants me to put an input as to what the what test file am I referring to. So I can press tab again, and you notice it won't actually. It won't allow me to continue. It'll tell me the 2 options that I can choose from. So I have to give it some input. So I only really want the 1 text file. So I just put a dot just to complete it, right? So I'm referring to this file, not this file, right? And you just hit tab again and then it's finished. So, okay, so we can run the cat command and there it is. There's all the information that you wrote inside of the text file. And it's going to fill up this entire, it doesn't matter how big this text file is. It's going to cat out all the information that was written on that text file. And that's really, really, really helpful. So, okay, well, Sam, I kind of want to make it so that, I'm not going to get the phone, by the way. I kind of want to make it so that I want to copy this file somewhere else, right? I don't want to remove it, cut and copy it, but I kind of want to copy it somewhere else. Like say I want to kind of copy it inside of, I don't know, downloads, for instance. Okay, well, we can use the CP command, which stands for copy. And the copy command, we can look at the manual of copy, and we'll notice here that, okay, for the synopsis, yeah, I know we have the house phone because we have to connect our security system to it. I kind of hate it. So the interesting thing is that when we have the copy command and we're looking at the synopsis, so the synopsis basically just means what's its usage, right? So what is it going to look like when you actually type it out? And it's going to ask for, okay, well, blah, 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 options. We don't need any additional options because it's not a folder, so we're not going to have it be like recursive or anything. But it says here, okay, the source needs to be specified first, and then the destination of where I want it to go needs to be next. Okay, well, that's kind of helpful. So that means that you're not like screwing it up when you're actually typing out the command. So, okay, so we can type in CP, and of course we can use test, and I want it to autofill. Actually, I want it here. Hang on, let me get out of here. All right, there we go. So now we can look at that again, and I'll be teaching you guys that command in just a sec. So what we can do is we can say CP test.txt. Now, Okay, well, you can do this a couple different ways. You can specify, the downloads path all the way from root and down. But since you're already in this directory, you really only have to tell Linux how far you want to go relative to the position of where you're standing, right? So remember, you can determine where you are by typing in PDW, right? And that tells you where you are. But since test is really just right outside downloads, all you have to do is just do this. Oops. Right? And then you're done. That should now, this complete command should make it so that it'll just copy the text file into downloads. And then we can hit enter, and it's finished. And we can double check that for sure by going inside of the downloads folder, and we can hit ls, and there it is. And, well, Sam, did it copy over the data? Well, let's see. And there it is, a complete copy. Now, what if I want to make it so I want to move this text file somewhere else, right? So I want to make it so that I want this text file to go to, I want to move this specific text file to desktop, but I don't want it to be here anymore, right? You're basically cut and pasting it. Okay, well, we can use the command mv, which basically stands for move. And move has the exact same setup as CP does, right? So you can just say move text.txt to desktops, right? And then you just hit enter. And you can type in ls, and you'll notice that the text file is not there anymore. But when we go into desktops, there it is, right? And I'm sure you guys can assume that the data that was associated with that text file was also transferred. Okay, well, I'm kind of bored of this text file already. I kind of want to get rid of it, right? Well, there is a command called rm, right? Oops, my apologies. Called rm. Now, rm basically stands for remove. Do you guys kind of see a pattern here on how the basic commands are labeled acronyms necessarily of the words of what they're supposed to do? And that's usually the case, right? I mean, it's the people who built this tried to make this as simply remindable as possible, right? So, okay, well, I want to get rid of this text file. All right, well, that's fine. So what you can do is you can just type in rm, and you can say test, and there it goes. It's gone. So now there's no text file anymore. But as you can remember, there is a text file, the same text file that we made inside of downloads, right? So that's kind of like the basics of, how to kind of move around and move a file. Oh, there's one last thing I forgot to mention. If you want to create a directory, so say you want to make it so you want to make your own folder. You don't like any of the names here. You want to make you want to make a directory called Samuel is the most amazing person ever, right? And you want to make it so that it's just, you want to make your own folder that holds the data that you want. Well, you can just use the make dir or make directory command, right? So that's pretty straightforward. So we can hit enter, and you'll notice that now there is the Samuel is the most amazing ever folder that exists inside of this current directory that you created it. Okay, and keep in mind that the color, ls, most amazing what? I don't even know anymore. So the thing is that when we have these colors, do you notice there's kind of like color coding that's happening? That's because that color coding gives you a bit of a general synopsis of what kind of file it is, right? So, or what kind of what is it, right? Is it a folder? Is it a file? Is it an executable file? Is it, all that kind of stuff? And it's different colors for each and every different kind of operating system, right? Or distro that you use. You can customize them if you want, but for the most part, from what we can see with this stock Ubuntu, dark blue means that it is a directory, and white means that it is a text file and it is non-executable. Okay. So now that we're done with the basics, we kind of want to talk about the idea of file permissions. So when we look at Linux, one of the biggest things that I like about Linux is the ability to work with file ownership and file permissions, and the fact that I want really one person to have access to it, and that's it, kind of thing, right? Now, Linux also has something called system users, which means that if you want, like, to save memory, right? If you want to make it so that you want Minecraft to not run as root, because if you had like a Minecraft process, for instance, run as root, it's going to take more memory, and that's not very efficient. And that also leads for possible exploitation issues as well. You don't want Minecraft running on root. That's not, that's not a good thing, right? So what we can do is we can say, okay, well, let's make it so that Minecraft is being ran by a system user, right? And well, okay, and you're starting to build the directories and everything like that, and you're saying to yourself, geez, I really don't want any other user to have access to this besides the Minecraft user. I mean, there's really no need to, right? So, unless the users that are above in permissions to the Minecraft system user, such as the administrator like myself or the root user, that's that hierarchy breakdown. I really don't want anybody else touching this directory, and I really don't want this system user to be able to touch any other directory besides the Minecraft directory. Well, how do we set up file permissions, file ownerships? And by file I mean folder permissions as well, right? Well, that's pretty easy. Linux has a pretty awesome way to do that. Now, when we talk about permissions, we can kind of go back and we'll say you want to like actually view the file permissions of like a certain kind of file. So right now we'll hop into downloads again, and there's our text.txt, and I want to know necessarily what's the file permissions, like who has access to what in this case. Okay, so I can type in ls-al, and that's the argument to kind of look at like the extended information of the files that are currently listed in your path. Okay, so these two dots basically signify going outside the directory. So it's referring to the directory itself and then outside the directory. Okay, and that's just general knowledge you just need to understand. But you'll notice here, okay, what is all this? Right? What does this all mean, right? I don't know what that is, right? Well, in this case, this is actually the information that's going to tell you, all of this is going to tell you exactly what you need to know in terms of file permissions. So we can look at, oops, I'm so sorry. We can look at the information regarding, well, okay, how do you read this? And this is kind of like the cheat sheet to kind of look at it. The first three values are specified to the owner. And the owner is specified in this value right here. So in this case, the user test is the owner of this file, which makes sense because I created the file called test. Okay. The next set of values right here is going to deal with, I'm sorry, actually, it goes like this, and then like this, and then like this, right? This first bit here is basically telling you whether or not it's a directory or not. Right? So in this case, since these two are directories, because they're technically referring to the directory itself or outside the directory, that is what that little D stands for. So, okay, so the first three sets after the D value is dealing with the owner of. The next three is dealing with the group. Now the group is specified right here. And groups are really neat because what you can do is you can do exactly what it sounds like. You can group users together under one single condition, right? So I say I want like I want the owner to have full access, but I want a particular set of pre-existing, a group with a bunch of other users that use this Linux system to only have the capability to read it. They don't have the capability to write in it, and they don't have the capability to execute it either, right? And then the final one is the world. So world basically just means any other kind of user that doesn't really have permissions. It's really just doesn't have administrative access, doesn't have whatever the case may be. They can read it, right? All they can do is just read the information. They can't write it, and they can't execute it. Okay. And that's what basically these stand for right here. R means read, W means write, and X means execute. Okay. And it's also specified down here. Now, what's the dash mean? Well, the dash means that they just don't have that permission. it's non-existent. The file doesn't have that person specified within that 3 sets is not allowed to work with it. Okay. So, well, why is it formatted like this, Sam? Like, what does that make any sense? Well, it's because it's formatted similar to something in octetal, or octal. Sorry, that was really bad. Octal, right? So if you wanted to make it so that, okay, well, you just wanted to quickly change the file permissions across the board here, but you didn't want to change the users and groups like that, you can use octal values, and I'll be showing you how to do that. And these octal values are literally bit values. Like it's pretty funny because whatever. So you notice that, you know, if I type in the command, which I was supposed to show you this later, but if you type in cmod, which basically stands for change modify, I think that's what that means. But it's basically just the command that you would use to change the file permissions of a particular file or folder that you're working with. You would say, okay, well, I want, you know, this, I want everybody across the board to have rewrite, you know, access to the main, you know, the text file here. So I can just type in 777, which basically is just the, you know, the first 7 for the first 3, the next 7 for the next 3, and the final 7 for the final 3. And that's basically just telling it on each one that every single person, right, the owner, group, and world get to have the capability to read, write, and execute, right? And you can hit enter. Oops, is that right? Oh, did I use the wrong command? Sorry, I think I got ahead of myself. Did I get ahead of myself? Oh, I'm so dumb. I didn't include the file. So I actually have to include the file that I'm working with, right? That's, you know, that's kind of important. My apologies. So once you have the actual file that you want to modify, you just hit enter and you're done. And to triple check to make sure everything worked, well, you can just type in ls-al again, and you'll notice that now the owner, the group, and the world have the capability to execute this file. And now you'll notice that since it's become an executable, it is now executable. And I maybe got a little bit ahead of myself because there is a way to make it so that it's executable other ways. This is not good practice. I hope to never find a file on your computer that has this kind of permission, because in reality, you really only want to turn that on if you think there's a problem with a file permission somewhere along the line. And that's pretty much it. You need to have very, very, very strict user and group control. You know, that's incredibly important. I can't stress that enough. Okay, so, well, I kind of want to change it back. So we can kind of go back to the command and, you know, you can look at the cheat sheet. Sometimes I even have to, so don't feel bad if you have to. So in this case, I want it to just be 6. Whoops. Is numlock not on? No, it's not. 6 for the owner, 6 for the group, and then as the final, I really only want, you know, people outside to have the ability to read. So 664. Okay, and type in ls-al to triple check, and it looks like everything's good again. Okay, pretty straightforward. So now we're going to be kind of talking about, as you already kind of saw, we're going to be kind of talking about the idea of permissions and also what, you know, what commands you would have to use to get through this stuff. So I'll keep that octal bit thing open so that, you know, you guys can kind of experiment. But the first command that we're going to be looking at is the // basically just means execute. So you actually want to run a bash file inside of the Linux system. And we will be talking about that later. I'm not going to do this immediately because there are like a few things that I do want to talk about before we do that. So cmod stands for change modifiers, and that's the thing that we use here. These are technically called, I'm sorry, I remembered when I was talking about it. It's basically changing the modifier values of the Linux subsystem. chown basically stands for change ownership. So you're changing the owner, right? You want to make it so that the owner has changed to whatever value you want it to. If you have a separate user, say you want to make it so the owner of this is root instead. So that's the other user I know is there. So you could just say, you can say chown root, and then the file, so test.txt. Now here is a problem, right? And the problem, I knew this problem was going to exist. That's why I typed it now. So what actually happened is that I don't have permissions, because the thing is that the test user is below root. It doesn't have the capability to just say, oh yeah, no, this is a root thing. Root has to do that. So in order to, there's a couple different ways that you can do this. You can use the ID, you can use the command sudo, which basically means, okay, well, anything that's going to come after sudo is going to be run as the highest permission level. It's going to be ran as root, right? So nothing's going to stand in the way of this system. Now, I don't feel like typing out this full thing again after typing sudo. So what you can actually do is you can just type in sudo and then 2 exclamation points. And it'll actually, 2 exclamation points actually just runs the previous command that you typed in. So like usually this happens, you know, if you type in a command and you're like, oh shoot, no, it needs to be sudo, but you don't want to type out the whole command again, you can just type in sudo exclamation point, and it'll run the previous, command, which is really, really, really nice. So now it's asking you for the password. This was the password that you set when you first set up the Linux box. So you can just type in, you know, whatever your terrible password is. And once you type it successfully, it's going to just bring you back to the prompt. And to triple check the actual owner change, you can do ls-al again. And you'll notice that the owner has now changed to root. As before, it was test, right? That's really nice, right? Really, really, really nice. So that kind of makes sense. Somebody's texting me. I hope it's nobody important. Nope, nobody important. Okay, so now what we're going to do is we're going to look at change group. Well, change group is basically the same thing, so I'm not going to kind of dive into that. It's the exact same thing. If you want to change the group, which is basically this value here, you do the exact same thing over again. But I kind of want to change this back to, I don't want this file to be in root anymore. That's, as the owner, that's kind of much, right? So what we can do is we can type in sudo, and actually we can even press the up arrow to look at the previous commands. It holds a bunch of previous commands, so if you type up, it literally just brings you to wherever you are. So I want to make it so chown, but I want to bring it back to test, right? And what's cool is that in a notice how it didn't ask me for my password again? If you're in a pre-existing session where you've already typed in sudo, it's not going to ask for it again, which is kind of nice. It kind of depends on what you're trying to execute though. Okay, so now triple check one more time. Notice, all right, now we're back to test. Cool, everything's all good to go. So, okay, well, what if I wanted to, run a bunch of stuff? I really, really, really want to make it so that I'm just running a bunch of root. I don't want to hit sudo every time. Now, I don't usually suggest this, but we're going to perform something what's called elevation, right? So what we're going to do is we're going to say sudo su, which basically just stands for super user. We're going to be elevating yourself to the highest that you can, right? So when you type in sudo su, okay, now I am running as root, right, in the text box. So no permission problems. Everything's got to be just fine unless it's some kind of weird permission that even root doesn't have access to, maybe some kind of system user thing. That is what is going to happen here. So, well, I don't really want to be in root anymore because there's really nothing I need to be doing in here. So you can just type in the command exit, and it'll bring you out of the sudo, the super session that you placed yourself in. UMask, to just kind of give you a better understanding of UMask, I'll type in the man command. Oops, I forgot. I forgot about that. It's a shell command. So UMask basically just deals with information regarding files. So we can do, oops. Did I just totally forget what UMask does? I don't usually use that command, but there's something that I think I should have talked about with this. I don't know why This is kind of embarrassing. Okay, there we go. So display or set file mode mask sets the file creation mode to mode if blah, 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 blah. UMask. What? Okay, well, do I just type it without an argument? Interesting. Oh, that's right. That's right. Okay, so what UMass does is it basically just tells me how many different entities are within the set. So it's going to include, so it's basically counting how many things are within this folder, right? So, and that's going to include the pre-existing directory as well. So if it was just the directory, so if it was just empty, right? So if I removed test, right? And then I typed in UMass one more time, oh, maybe I'm not, maybe UMass doesn't, maybe there's some weird update thing that's happening too. I could be talking about this wrong. You know what? Just ignore that command. I never really seem to use it. It might be doing something that I may not know. So I apologize for that. Okay, so the next one we're going to be talking about is ID, right? So ID basically just, it prints the effective users, right? So users and group IDs of a, whatever the ID of the file is, right? So we can type in, you know, ID test, right? And this sort of information basically just tells you, okay, everything that you need to know, the UID information, the GID information regarding this user, right? And that's something that, you know, if you start to kind of dive more into the idea of file permissions for stuff like that, and you really would just want to kind of get a general report, ID is really the best way to do it. Password, the password file is basically just used to change the password of a user. If you're only confined to a, you know, terminal-based system, you really would have to use the password command in order to change the password of a user. And then the type command basically just deals with, okay, well, what type of thing is this? Say you want to like identify, okay, well, what is type? So we can just do touch.test.txt, right, again, so we can populate it with something. And I want to know what test is, right? Oops. Does it not? Oh, my apologies. Nothing appropriate. So the thing is that since there's nothing populated in here, the what is command is not going to work. And the idea of the, oh, where did it go? Did I lose? Where'd it go? Type, oh. So, and again, I'm not entirely sure what this command entirely does, but the man.type command, I guess, so there's no manual entry, so it has to be a shell command as well. This is kind of weird. I thought that the type command makes it so that you can look at a file or any kind of type of directory. Well, let's try on a directory. So we can say type, I don't know, videos. No? Type is a built-in. Oh, help is a, oh, that's right. Okay, so type basically tells you about the idea of commands. So you want to know what kind of command it is, right? So like say you want to know what kind of command, I don't know, bash is, right? So we know that bash is a certain kind of file, right, that exists inside of user, bin, and bash. This is kind of helpful if you want to determine what the file location is of a certain kind of command and also what it is. This was the command that I was looking for at the beginning when I was trying to explain to you the difference between shell commands and normal commands. Type is the thing that tells you that. Realistically, you would really only want to use this if you're first experimenting and you don't have any clue or idea what this system is, right, or what that actual command is. So we're going to be just talking over some more like kind of general stuff. Alias is used when you want to create a like a command association with like a file. So you want to make it so like that, like on my pre-existing here, I guess I can kind of show you because setting up an alias can be a little bit of a pain, but I can kind of show you on my current system. If we go to the PuTTY, okay. Oops, typed in the wrong password. I hope you guys like my terminal. So this is my system, and I actually have an alias that I set up that's called MC console, right? And what MC console does is it brings me directly to my Minecraft server console, right? So like say, oh, there we go. Yeah, thank you so much, man. UMask is used for looking for, it's asking for what kind of user you are. So like it's going to give you the bit value related to what user you are signed in as, and then the permissions I think that are associated with it. Thank you so much for reminding me about that. I totally blanked on that because I'm so freaking nervous. So when we have an alias set up, that alias is basically just determined to say, okay, I kind of don't want to type out this full command to get to my Minecraft console, so I can just make it so that, all right, well, I just want to make the alias that says MC console will bring me to my Minecraft. And that's kind of what alias does. It's very useful for the most part. But keep in mind that in order to make it so that an alias works every time, you have to specify in a folder path that we will be talking about a little bit later. Okay, grep and pipes and redirects. So when we want to kind of take the output of something and we want to place it in like an error log file or something like that, that would be kind of the best. Grep and pipes would be the best way for you to perform such a thing. Sorry, I was... Oh, thank you. I appreciate it. So the best way to kind of go along with this is to say, okay, well, God, you know, my program isn't working, right? I really want to make it so that I can have like the output of something. And I really wish I had something that I could kind of show you to like debug, but I don't think there's like any known programs that I have in here that I can show you, but I can kind of show you the structure. So you can say grep, right? And then you can say, you know, whatever, program, whatever, right? And what you can say is that then you can have a pipe. And that pipe basically just means it's literally a pipeline. It's taking the information, the output that grep is grabbing from this program, and it's going to output it to, you can even have it create a file called output.txt. So what it's going to do is it's going to take all the information coming from this program, the log files, information, error files, everything. It's going to pipe it to a file called output.txt. Right? And that's basically how you would like debug something. And that's always really, really, really helpful. Now, there is a difference between a pipe and a redirect. A redirect, right, is this little symbol right here. And redirect basically means that if you want to write a command to a file, right? Whereas grep, it's more just text to a file, right? So grep, you have to treat the redirect very cautiously because redirect, for the most part, I was reading something actually the other day of somebody explaining the idea behind redirects and pipes so that I could get a better understanding. And really, and this is something you never, ever, ever want to do, but what he basically did was he redirect the less command into one of the main file systems in root. So, and it didn't say anything about it because basically, you know, it took the command, right? But you know, what it actually did was it took the less command and it wrote over every single value, like the file information inside of that directory, right? And that's really bad because if you do that, especially in a root situation, you're at root, you're in sudo, and you're in the root directory, and you do that. I mean, you can corrupt your file system if you do that, and that's not good. So treat redirects with caution. Don't ever go out and just, hit the ground running and keep using redirects and stuff. If you honestly don't have to, try to just use pipelines, try to diagnose the issue. Don't try to do a bunch of redirects and all that kind of stuff if you really don't need to. I never have had to use a redirect for many different situations unless it was like something very catastrophic happened, especially like in rescue. But that's kind of the best way to do it. You would really only the most that I use redirects is actually in bash files. Okay, so the cat command, we talked about that. So that's just concatenating. So we did talk about that. WC is word count. So you want to know, okay, well, let's create a new file. So we'll create a new file, let's say touch. You can also just do nano immediately and it will create a file for you. All right, you just type in a bunch of information, space, more information, space, more information, space. And you can type in, control outright, make sure it writes to the file. And now we have a test. Oops. Now we have a test file inside of here. So I want to know the word count of that text file. So you can just type in word file.txt and it'll give you all the information you need right here. Right? Pretty nice. So I believe this means one line. It's 3 words because I had 3 spaces. And then this is how many characters it had. I believe that is the output. This is this is honestly very great. Thank you so much. Oh, thanks guys. Thank you guys. I appreciate it. So that is actually kind of how you would read the information. So you want to just know, generally how big the file is in terms of like word information. That's kind of how that works. Additionally, and this was something I failed to mention, if you type in ls-al, this line right here tells you the size of the, it tells you the size, how big is the file in terms of bytes. And that's just, that's something to know about. Not bits, but bytes. Just keep that in mind, which is useful anyways. I don't know why you would want to have it in bits anyway. Okay, so now there's a couple other things we can talk about. We can talk about head. So when we say head, then in the text file, oops, and we look at it, it's going to basically give me the heading information of the text file. Now keep in mind, it's not a very big text file. So head and tail, as you can assume, tail probably does what? Looks at the very end of the text file. It's going to basically tell me everything because this text file isn't very big. But say you only really wanted to know, like, the last ending, string values of a text file, you can use tail. But if you want to know the head values, you can just use head. That's really nice. Okay, well, we have a lot of commands up here. This is getting kind of, clunky. Why is there so much garbage that I don't really need anymore? Well, you can just type in the command clear, and it cleans it up. So now there's no more, there's no more information, and you could still refer to all the previous commands that you had. So that's always very nice. Of course, additionally, you can always type in history if you really wanted to, and you could look at all the commands that you ran beforehand, and it puts them in really nice order. So that's always really nice. No, hey, shut up. I know I spelled it wrong. And then we did talk about the exclamation point. Remember, if we just type an exclamation point, it'll just run the previous command that was set before. So that is always really nice. All right. So now we're going to be just talking about some basic system processes. When we talk about system processes, right, I have to be honest with you. There is tools that do exist out there. Like one, for instance, that I do tend to use is Glances, that really just kind of gives you this really nice overlay of everything I want to know. Yes, it does take some processing power, but it's really nice because it's just one kind of quick overview instead of typing up a bunch of commands to make it. And I can show you guys Glances if you want. Realistically, it's not always the most fun to just continuously type commands if you want to know stuff. But if you want to just know individual stuff and you don't want to type out the entire Glances, then you don't have to. And that's what these commands are. So when we type in PS, that basically tells you the processes that are open. So the only 2 processes that are open is the bash file and then the PS command that I ran. It'll tell you the PID, which means the processor ID information. So if you want to kill a task, you have the information to basically kill it. It tells you the time that it was ran. It also tells you the type that it is. That's always kind of good information to know. Now, when we type in the command top, now it's going to give you kind of a system overview of everything you want to know. It's in real time, so you can kind of look at all the information. There's one user that's signed in right now. This is the load average information. This is the amount of tasks that are being ran. This is one that's running. These are the rest that are in hibernation mode or sleeping. We can talk about stopped processes a little bit later with a couple different kinds of commands. It talks about the memory information, what is free, what isn't, what is being used, what is the total, and then swap. Now, does anybody have any understanding of what a swap area is? Linux is a little bit more known for this, but I'm willing to take answers from anybody to know what a swap area is. I know what it is, but I just want to make sure. Does anybody have any Any explanation to what a swap area is? Yes, yeah, that's a very good way to look at it. It's a Windows equivalent of virtual memory. That's correct. But does anybody know where the virtual memory is being stored? I kind of gave it away when I said stored. That's the swap file. That's right. But it's not being stored in memory, though. It's being stored somewhere else, a different part of the computer.
Storage.
Yes, it is stored in storage. That is correct. And it is actually, that's right, hard disk. It is actually being stored inside of a separate partition when you first set up a Linux system called swap space. Now, this is important for a couple different reasons. Say you have a really crappy computer that only has like 2 gigabytes, Raspberry Pi, and you're not very good, you want to run this very large program that takes just over the amount of memory that is being used currently. So the Raspberry Pi, for instance, that you have is 4 gigabytes. Well, okay, well, shoot, right? If we go over that memory and we don't have any place to put it, you're going to have possibly Stack Overflow errors, and you're probably going to crash your system, right? You're going to break things, right? And that's not good. So what if we kind of dedicated a space where we could put the extra memory information into storage? Now, it's going to be slow, but at least it won't lose any of the information that we want, right? So that's pretty nice. And that's exactly what a swap area does. So it tells you here, so we have this many total, this many free. That's good. That means we're not using any of the swap space. And that's good. You really only want to use swap space if you're in a really bad situation and you don't want to, you need to get yourself out fast and something happened, right? So this is all the information that you would want to understand. This is the CPU load, the memory load, kind of the PR information, the NI information, the user, the PID information again, virtual information, so like the virtual container stuff, and then the, somebody remind me what RES stands for? I can't remember. Josh, Chen, I'm looking at you. I really don't. What does RES stand for? So I believe PR stands for processor information. So it's like the in and out. So like when you're looking at like I guess the best way for me to explain it, I really don't know much about this because again I'm not a software guy, but I believe it has resonance size. Right, so it has something to do with like the non-swappable physical memory the task has to use. Okay, yeah, so it's basically just the communication between memory and processor. And that's what I thought it was. It was something that had something to do with the back and forth of the memory and CPU. Because remember, if you think about it, a computer realistically needs power, a CPU, and memory. That's it. Right? You can technically live without storage because you could flash all the memory, you can flash all the information onto a flash memory or memory beforehand. And I have seen that done, right? Realistically, you only need the two, right, for a digital system. That's kind of like the best way to put it. But yes, no, that is exactly right. And it stands for residence size. I'm going to have to do more research on that. So thank you. Okay, so you can exit this by just pressing Q, right? And you'll be brought back to the command prompt. We can talk about jobs as well, but jobs is basically going to show kind of the same information that tops does. Yeah, so there's no jobs being occurred right now, so therefore it's not going to show anything. Screen is something that is not pre-installed on Linux, but it is what I tend to use when I want to have multiple windows open under the same process, right? Imagine like a window, and this is realistically, you only really need to use screen when you don't have a desktop, right? You don't have the capability to just go over and just click and say, new window. You know what I mean? It's basically just allowing you to have a completely fresh new window that you can reconnect to at any given point. However, I do not ever suggest somebody to run a process or just like whatever you're trying to run in a screen and just leave it be. Use a screen if you realistically need to open a new terminal window for any which case, but it is not for a process. When you're creating a process, make sure there's a specific system user, make a very nice, and it doesn't have to be specific to just that, but it'd be nice if you created some kind of good hierarchy that makes it so that you have a dedicated system user for a dedicated process on a dedicated system. And that's kind of the best way to look at it. Kill and kill all basically stands for the idea of, well, kill requires a PID input. So like say I wanted to kill, any of the information that was stated above in terms of like a process, right? So I can look at the processes again by typing in PS and say I want to like kill the PS command. Even though it's done, I would just type in kill and then the processor ID right after that, which is located right here. Kill all just basically means it's going to kill all the processes except the important ones. So just use that safely. Shutdown does exactly what you want it to. It's going to shut down. Now, shutdown by default, if you just type that in, right, it's going to give you a scheduled time to shut down. If you want it to shut down like immediately for whatever which case at all, you can just type in shutdown -H now. Now, I'm not going to punch this in, obviously, because I do not want to restart the system. So that is one way that you can punch stuff in. Again, I'm not going super deep into all the arguments for each one of these. Each one of these commands has arguments that are specific to certain kinds of situations. So if you're really curious or you think that there's something that you need to do for a process, make sure to use the man command or the help command in order to help you get to where you need to be. Reboot does exactly what you want. Reboot does not do a scheduled thing. If you type in reboot, it's going to reboot. It will ask you, if I try to do that now, oh wow. So I have to admit, I kind of thought it was going to say no because I didn't give it permissions. That's on my other system. I apologize. I forgot to set that up. So reboot is going to reboot the system. That's I apologize. So okay, well, when my DOS box is finally, when my stupid Ubuntu box decides to open up, we're going to be going over the apt command. And apt is something that we would use typically for updates, right? So you want to update something, you want to make it, so that you actually get those daily updates all the time. You want to change the ability for you to have unstable updates or any of that kind of stuff. I'm going to show you just two forms of it, the update command and the upgrade command. And then from there, we will, I believe there's like one other slide after this, and then we can kind of go into our examples and then maybe questions. Well, not maybe, questions. There will be questions. So apt is yes. So Debian-based systems only have apt. I believe for some other kind of weird ones, they use yum. That's like for Red Hat, like Fedora and all that kind of stuff. Those would typically use yum. There are different update commands for across the, realistically, you would only really be using apt or yum, I believe, for update stuff. I could be wrong. But as far as I'm concerned, that's what I understand. So, okay, well, say I want to update, I don't want to actually upgrade everything yet. I don't want to change stuff. I just want to see, what exactly, I want to load the updates so when I have the upgrade available, I can. Yes, I believe it is also Pacman for Arch. I'm really not too sure. It's different across each kind of operating system. Usually they'll tell you, right? That's something you definitely would need to know. So we can just type in the command apt get and then update. Right now, you'll notice there's a very big problem here. It looks like the apt command can't actually read the information that it needs to in order to actually do a proper update. So, and that's because I'm in a current user that doesn't have the permission to update. So we have to use the sudo command, right? And I don't want to type out that whole thing again, so I can just type in sudo that. Then we have to type in our password. And it's basically going to go through and it's going to read all the update information from every source that you created. Now, keep in mind that if you add like a git list or you add like something that you want it to be constantly updated for, this command will also update those packages as well, if properly set up, right? So workshop for another time. But when we talk about like git and any other kind of like software package at all, update install update is going to update the information for those packages as well, as long as you set the proper pointers. And then, of course, we can always upgrade, right? And now you can kind of see everything that has to be updated, right? And it's a lot of stuff. Now, normally I would press yes, but because I want to save time, I'm just going to press no. So it aborted the install. But if you press yes, it's going to go through and finish up everything. Now, this was kind of one thing that I did just want to talk about. I have to apologize. I really couldn't think about everything I wanted to put on here because it was like a lot. But when we talk about places in Linux, I'm usually talking about directories. And when I refer to places that are places of importance, I'm usually talking about directories of things that like you would want to interact with. So for instance, in the directory etc.profile, there is a global configuration script that basically applies to all users. It's a startup script. So like say you wanted like your alias, like I stated before, to run up every time you want you want to be able to make it so the MC console example that I showed before works, right? Oh, no, thank you, Ferris. No worries. I'll see you around. So the thing is that what we have here is, well, just all of these are really just the only ones I could think of immediately, but these are kind of the places you would want to create startup files, right? So if you wanted to make a file that was being read or a command that runs automatically, you would work within the bash rc file. And a lot of Linux users, I know there are some here, have definitely made modifications to their bash rc file because that is where you would want to state startups. And when I say startups, I'm not really just thinking about just like a Windows startup where it's just like a program, right? It's more like, okay, well, I kind of want this command to be ran, but I also want the alias of it to be initialized every time. And I want this program to run, but I kind of want it to run in the background. So you can specify it as a command. And that's just the default. And that's what's really neat about this kind of stuff. This is like kind of like the end. We can go over more if you want. I'm here to help or ask or talk about anything else. If anyone has any sort of questions or comments or something I may have covered or missed that maybe I should, this is the time now for you to ask or to discuss, or we can even go over like a bash example if you want. But that's totally up to you guys in terms of your guys' time. So I guess this is the part where I just say thank you. Thank you all for listening so much. You guys have been such an awesome audience, helping each other out and also helping me. I am not a immediate Linux user. I've really only been using Linux for the past year and a half now, right? I mean, I really only started diving into it because I realized that there is such a oh, thank you. I am not a Linux professor. I am far from. There is so much that I have to learn from Linux. I mean, I have learned to respect the idea of computers so much more because I have gotten to experiment with so much with computers, with realistically free computers that were just given to me, and then I'm just like, oh yeah, let's install Linux and have some fun, right? Let's make a Minecraft server that people can play on, or let's make I've always hated the idea that I never dedicated to torrents, right? So let's make a torrenting engine as well, and while we're at it, let's make it so that everybody in my house doesn't have to suffer from ads, right? So I make an ad block system, and that's all being programmed. So I think you should cover LS. Oh, Bobby, to kind of answer your question about that, ls-al actually does show you hidden files, I believe.
Oh, it does?
Yes, it does. Yes,
Okay.
it does. Yes. Yeah, but thank you for asking me about that. That's a good idea.
Okay.